Hello, everyone. So now we are going to discuss about chemical reactions. In this lecture, we'll discuss about the different types of chemical reaction. We will see what the chemical reaction means. So when you can talk about and when you can see that there is a chemical reaction happening or there is a physical change only. We will also discuss some of the aspects, the laws which the chemical reactions follow, and according to that, we will see that how the reactants are converting into the product one. So far, you have a concrete concept about the atoms, elements, molecules, and how they combine to make the atoms are combining to make the new molecules and the compounds one. We also have talked about the chemical equations. So chemical equations are basically the mathematical expressions by using their symbols, by using their molecular formulas to express a chemical change which is happening in a mathematical way. Just with the equation, you are able to see the whole of the process that from which it has started, what are the different intermediates, and what is the final product. So basically, the chemical equations or equations are used to express or to mention and to show off the chemical reaction in the mathematical version. We'll define what the chemical reaction is for the general understanding that you should know that how we can define a chemical reaction is happening. So, a chemical reaction is the change in is a change of a substance into a new species, into a new compound, one that has a different chemical entity or identity. What does it mean? For example, if there is A and that is converting into the B, so that is basically a simple change. So A is a reactant, and that is simply converting into the B, and the B is a product. So in any of the reaction, we use it in a way that there is an arrow, full-headed arrow or half-headed arrows are used to write the chemical equations. So when we draw the full-headed arrow, this means that we are mentioning a irreversible reaction, that this is processing in one direction, and that is the one focus direction of that reaction. When we draw in that form, the half-headed double arrows, so it means that this reaction is possible from A to B and B to A. So this is the reversible reaction. So equally, that is happening in a forward direction, and that is happening into the backward direction. So um, when A is converting into the B, so that is the simple way to express the reaction. But there could be the different types, which we'll discuss later, that that reaction can happen, that either we are providing any of the energy, either we are providing any of the other reagent to mix with that, and then we are getting that one. So the starting point or the initial substance is called the reactant in terms of the chemical reaction language, and the final which we are obtaining as a result of a chemical reaction is termed as the product, right? So, a chemical reaction is usually accompanied by easily observable physical effects by which you can say that that is a chemical reaction which is happening. So, obviously, you can see sometimes this is very visible, and sometimes you have to use some other techniques to see that what the reaction um, has happened, and either your reactant has converted into the product. But right now, we are keeping in our mind the easier and the more general perception where you can see and where you can observe the chemical reaction from the physical effect. But do remember, it's something when you are doing this in our labs, and we are conducting some of the reactions, though they are mostly in cases, they are the color change, they are the physical state, which is what the change is happening. But sometimes the reaction visibly to your eye, there is no change at all. But when you monitor the reaction, or you are working up that reaction to to get the final product, or you are using either some of the techniques to see that either your reactant has converted into the product one. But usually, how you can say what are the different physical effects which are happening when there is a chemical reaction. So there could be the emission of heat and light. There could be the formation of precipitates. So the precipitate means there is something, the solid material has formed by the mixing of the two liquids, and that something is settling in your vessel, in your glassware. The C is there could be the evolution of a gas. So that gas could be the colorless, odorless. That gas could have the distinct odor. Sometime, as for example, we are mixing like in any of the soda, when you add some of the salt. So basically, what is happening that there is a carbon dioxide which is producing. So that carbon dioxide is colorless, it's odorless, but from the bubbles which are generating, so you can see that evolution of the gas, so that gas is producing. Lastly, there's mostly, in some cases, there are the distinct color change as well. So, for example, if you just, you have seen in some of the titration experiments or in your daily routines, the most common example is you have seen the firework. So they are the different metal salts when they burn and or ignite in the flame, so they show some of the distinct colors. So that color is basically for the burning of that, and that is that flame is showing that there's some salt changes, chemical changes are happening. So that is the different visual effects or the physical effects which you can see through uh, to examine that either the particular change is a chemical reaction or this is just the physical change. So absolute confirmation of a chemical change can only be validated by chemical analysis of the product. As I told you, there are a number of different techniques which we use. We use TLC, we use a spectroscopic analysis, we use elemental analysis, so by which we confirm and validate that this reaction has happened. So generally we do examine their physical effects too, but absolute confirmation will be done when you have done the chemical analysis on that one. So for example, in our blood serum or some of in the pathology lab, there are the urine samples. So by the coloration change, that either that is a white urine or the yellow, so you may indicate that that could be the effect of this. But of course the absolute confirmation and the absolute report needs the chemical analysis, because that same coloration could be because of something um, different. So you have to report the exact information, that what is an amount in a quantitative way, and either that is because of the high content of something, uric acid, or the high content of something in your bloodstream. So that needs the complete chemical analysis. Now we'll see some of the common examples of the chemical reaction. So that could be sometimes tricky for you, though that's the most observable things. They're the burning of paper. So the burning of paper is a kind of example that you can't retrieve your paper back if once that has burned. So this is a chemical change, because that cellulose or that paper has burned, and that has converted into the carbon residue, and there was a heat, there was a carbon dioxide which has produced, and mostly there is a water content as well. Now the next example is basically the firework. So there are the different metals, salts, which are deposited on some of the very fine wire. And then when you burn this one, so you can see that this will impart a distinct color, and when it is basically reacting with the oxygen from the atmosphere, and then it is converting into another product. Now, another example which is on which we are or all of our structure, our physical activities are based. So that is what is happening in our body system. So you know that we take different components in our food. We are taking carbohydrates, we are taking proteins, fats, vitamins, and a lot of liquids. So where they are going, so there could be the question that how we are developing, how the regeneration is there when we have a wound or cut and our skin start then heal up. And though we take the carbohydrates and meat, but you never see that content of fat or meat or the carbohydrate is just hanging up in our body. So basically this is consuming in our body system, and our body machinery is using that, and it is processing that food items into the usable products that which are recognizable and which are basically usable in our body system to generate the new things, to heal up, to grow, to for the hormones and for the physical activities which we are conducting. So usually the most of the common example I can give you is the glucose. So the glucose is the carbohydrate which we take through our plant sources, which we are taking as a sugar, table sugar, and also from the juices and from the fruits. So basically, when the glucose, which is the 6 carbon molecule, then we are consuming that one, which is a and then it is converting ultimately into the carbon dioxide, water, and there's a lot of energy which is producing, and that energy in the biological system, in our metabolism, in our cellular reactions is called ATP, right? And ATP is basically called our cellular currency or energy currency. So as in our normal life, we have the money, we have the ATM cards, or we have the paper currency to deal in our daily routines, that we exchange, we purchase, and we buy something. So ATP is the currency of our metabolic system. So this is basically the ATP which is producing, which is sometime the input part that this is consuming to conducting some of the chemical reaction. Sometimes this is the product that we are getting when, especially when we are doing the exercise. So we need to do a lot of energy to conduct the physical activities, and in our daily activities too, when we're thinking, blinking eyes, moving hands. So there's also in terms of the energy which our muscles have, and they or transmission system is having. So that is basically our product which is formed by consuming the food item. So our full body system is having the number of millions of different reactions which are happening, and then they are consuming the high and very complex molecules, and they are converting it and decomposing or digesting in another way. They are digesting these molecules into the usable and smaller components which could be the part of our structure, and which will be eliminated from our body after taking or converting into the usable product which are required for our body system. Now, the next is the laws govern chemical reaction. So everything which we do and which we have to practice, that is under certain rules, conditions, and the laws. Similarly, the chemical reactions do follow some of the laws, and we should know, this is very important that we know these laws. So there are the three key laws for the chemical reaction. The first one is the law of mass conservation. So Lavoisier, who basically postulate that law is the law of mass conservation, which states that the substance are neither created nor destroyed, but rather change from during reaction from one form to another one. So we can see from the example, there is a zinc atom, there's the hydrogen chloride, which is the one hydrogen, one Cl, but they are the 2 moles of the HCl which are using for the one zinc, right? So we will see the reaction that this zinc, when combined with the HCl, this is converting into the zinc chloride, which is a salt, and it is liberating the hydrogen gas, right? So if you just look carefully on this equation, so there is the one zinc, there is 2 hydrogen, right? And there are the 2 chlorine. So we when we look at the equation, so there is a question that you always ask that to balance the equation. So why we need to balance the equation? Because it is to fulfill the law of mass conservation, because in nature, in reaction, so what is actually happening that we are not creating the mass or not losing that mass, it is just converting from one form to another. Now you can ask this that sometime when you are burning a very high amount of something, and at the end you are just getting the very small residue, so you can say, you may think that there is a mass which has lost. So that is totally wrong. Basically, the mass has not lost. This has converted into the other products, and that products are not visible to you, because in the paper burning, as we can see, the paper has a full, let's say, if you're just imagining that you are burning the full page, and when you get that has completely burned, so you have a very few residues of the carbon black ash, and where the other mass has gone, so that is basically has converted into the carbon dioxide and energy in the form of the heat, so that we can just feel or we can see, because that has evaporated and that is the part of the atmosphere now. But overall, that mass was not lost, so this has just converted from one form to another one. So sometimes the product you are getting out of that reaction, you can easily measure and you can quantify, but some time this has converted into the form which you can't collect, and which you can't measure as solid, as a tangible part. So the second thing law is the law of constant composition. So Prost's law of constant composition states that any compound always consists of the same ratio by mass of its elemental parts, regardless of the method of the preparation, right? So what does it mean? That if we say that there is a water molecule, and we know when a compound will call a water molecule, it has a 2 hydrogen, it has a 1 oxygen. When they're combined in that ratio that there is a 1:2, 2 is for hydrogen and 1 is for oxygen, then that is the water. Either that water is from the ocean, either that water is a tap water, either you has recovered that water from the sea or from through the filtration, or either you are generating electrically that water. So the water means the chemically that is combined in the same ratios. If you are writing H2O2, so that is hydrogen peroxide. This is no more the water molecule. So every compound, if we say, if we call a compound, so that means all over the universe, and whatever the method we are using to prepare that, chemically that is in the same ratio, uh, and in the same combination of that matter atoms which are making that molecule. Now coming towards the third law, the third law is the law of multiple proportion. So Dalton's law of multiple proportion states that two elements may form more than one compound, but with whatever the compound was, it would always contain elements combined in whole number ratio. So this is just the advanced form of the law of constant composition, right? So basically, here in an example, you can see there are the two different molecules, and both are having the same kind of elements, same atoms. So there is nitrogen, oxygen, but we are having the two different compounds out of the mixing of the nitrogen and oxygen. So in a one case, this is the nitric oxide, and the nitric oxide is the compound when there is the one nitrogen, it is mixing, it mixes with the one oxygen. So if we just look at its molecular weight and the amount or the mass of the each contributing atom, so you can see the molecular weight of this N nitric oxide is 30 gram, right? If we just combine the 14 plus 16, so overall net weight or net mass of nitric oxide, molecular weight of this one is a 30 gram. So there are the 14 gram of nitrogen, which is atomic weight of the nitrogen, and the 16 gram of the oxygen, which is atomic weight of oxygen. And then now the ratio is 1:2. But on the other side, if you just see another example, there is the two oxygen atoms which are combining with the one nitrogen, right? So here the overall molecular weight of this nitrogen dioxide, now you need to know that nitric oxide and nitrogen dioxide, they both are entirely different things. They both are the different compounds, they have their own chemical and physical properties. So their molecular weight is different, because now there is the one nitrogen and there is the 32 gram of the oxygen, which is the two atoms of the oxygen, 16 into 2, that is the 32 grams of the oxygen. And now the ratio is 1:2. Now this states that one atom, the two different elements, may form more than one compound. Like this is not necessarily that there is only the one combination the nitrogen and oxygen can make with each other. So there is another compound which they can form with the different ratio, and definitely that difference in ratio is generating a different compound. So as a whole, a compound has the constant composition, but the elements with the different combinations, they can make more than one compound with each other. Now we will see the types of chemical reactions. So categorically, um, in a more general perspective, they have divided into certain kinds of chemical reaction, because all of the reactions happening, they comes broadly under these um, reaction times. So that is the phenomena which is happening in this. So that's why they have categorized as this kind of reaction. But when you dig deeper into this one, and you are interested into the more details, so of course that depending on it, so there is a more explicit list, and there is a more detailed um, variety and categories of the eventual reaction types, that either that is the it is reacting with the water, either that reaction is under the catalyst, so that is termed as a catalysis in a more advanced node. But generally, when generally discuss about the chemical reactions, so they are divided into these categories. And if you go into that one, so they are the further subdivisions of each of category of these chemical reaction. So the very first one is a synthesis reaction. You may call it addition reaction as well. You may call it the combination reactions as well. So in the synthesis reaction, what is happening, that we are combining the two or more substances. So that could be the two, there could be a third substance also. They all three are combining, and eventually we are getting a single product, right? So this reaction can be represented by the equation, that there is the hydrogen gas, and we know the hydrogen do exist as a diatomic form. So this is the H2, and G is for writing that this is in a gaseous form. Now the oxygen again is do exist as a diatomic form because this is not available in nature as an elemental form. It's a reactive one. So for stability and to complete the octet one, this do exist in the combined form. So this is the O2 gas, and when they are combining, so there is the water molecule, which is the liquid in its physical state. So as I told you that the chemical reactions obey and they follow the laws of chemical reactions. So the first law we have discussed is a law of mass conservation. So it means that the atoms need to be balanced in this equation. So they should have in equal ratio, in equal amount moles on the both sides. So here that was H2, and when we get, so that was the H2O. So for balancing this oxygen, right? So we have to put the numeral 2 in front of that water molecules, and here you can see then when we have put the 2 numeral for balancing this oxygen amount, so we have raised that oxygen hydrogen amount by 2, right? So it means we can just add the 2 to balance the hydrogen to 4, right? So now this balance equation is also giving you the information about that for one oxygen molecule, how many moles of the hydrogens are required to convert into the 2 moles of the water molecule. So it means when the 2 moles of the hydrogen are combining with the 1 mole of oxygen, so you will get the 2 mole of water molecule. Now, the second type of reaction is a decomposition reaction. So as name state, so there is something that we are cleaving, we are breaking, we are damaging a bigger molecule. So here, this is an example. This is a mercuric oxide. And when we treat it, so that is a solid, and we are getting the mercury as a metal, which is at the room temperature in a liquid form, and there is oxygen, which is in a gaseous form. So now if we don't collect the oxygen, it means that is evaporating. So we will just only need to see the mercury at the end. So it doesn't mean that the oxygen has lost. So basically this has generated, but now this has evolved as a gaseous form. So the mass has conserved, right? So here again, we will balance the equation, and from this equation, we get the information that for the decomposition of mercuric oxide, what is after the decomposition of mercuric oxide, we get the 2 moles of mercury and 1 mole of oxygen. And if we just reverse the equation, so it means that the 1 mole of oxygen will combine with the 2 moles of the mercury to generate the 2 moles of mercuric oxide. Now, going to the next type, this is the combustion reaction. So combustion reaction are particularly and very specifically, they are about the reactions which involve the oxygen as a reactant, and and it is more applicable, and the most common example is the fuel, the hydrocarbons that they burn in the air, and they are converting into the carbon dioxide and the water. So when you are getting the product in the form of the carbon dioxide and the water by the reaction of a fuel or a hydrocarbon, and this is taking the atmospheric oxygen to burn that one, and uh, releasing overall the product as a carbon dioxide and water. So that is particularly the combustion reaction. Now, the next fourth one is the reduction oxidation reaction. So a redox reaction is one where reduction and oxidation take place altogether, hence the name. One species is reducing and the other is oxidizing in a reaction by accepting and donating electrons. So there are a number of definitions about the reduction and oxidation, and you should know that this is not limiting only to the acceptance of the electron. This is also mentioning if the oxygen is removing from one species. So this is basically this get reduced, right? And if something is accepting the oxygen, so that is that this is get oxidized. Another way is to define the reduction is that if something is taking the hydrogen, so that get reduced, and if it is removing the hydrogen, so that get oxidized, right? So you need to check on and to work on it to more to know more about the reduction oxidation reactions. So in equation you can see that whenever there is a reduction and oxidation reaction, so if there is something which is donating the electron, so definitely there should be the other partner which can accept that electron. So even only in that way that reaction will complete, right? So the reduction oxidation reaction is that one species is reducing and the other one is oxidizing. So here you can see that the zinc and the copper, so this is a reaction between the two metals, two transition metals. So one is a zinc, another one is a copper. So the zinc get, so here when the zinc is not written any of the charge, so this means that is neutral and there is a zero oxidation state, right? So when we look at the right side of the equation, now the zinc from 0 is converted into the 2 plus. So let me just convert into the pen. So this has converted from 0 to the zinc plus 2. So plus 2 means that whenever we are putting the sign plus or positive charge on some of the element or atoms, it means that has lost and that is deficient with that number of electrons. So it has given or it has donate these electrons to other species. So it means from 0 where it was neutral, now this is deficient with the electron by 2. So it means it has eliminated the 2 electrons. So when we will write it in only on in terms of the changes happen to the zinc, so this is a zinc which has converted into the zinc plus 2 electron. So we will write these 2 electrons which have removed at the right side if we are writing the equation in that way, right? So because these 2 electrons have eliminated, so that's why zinc is in the plus 2 form. And if you will write the zinc plus 2 electron and then the zinc plus 2, so that is totally wrong equation because you are writing the electron on another side. So here um, this means that when the zinc plus 2 will combine or take up the 2 electrons back, so then it will convert back to the zinc 0, right? It will get neutralized. So basically there is the removal of the electron. It has donate the electron, it has given the electrons to another one, right? So this is donating the electron. So the species which is donating the electron, so basically this get oxidized. So this is the oxidation reaction, right? So as the one species is reducing and another is oxidizing in a reaction by accepting and donating electrons respectively, right? So this is zinc 0 is removing the electron and converting into the zinc plus 2. So it means that has oxidized, it has removed the electrons, right? Now the reduction reaction is this one when something is accepting the electrons. So there is the copper plus 2, it was in the plus 2 form, means that was deficient by the 2 electrons. So now gaining the by after taking or accepting the 2 electrons, this is resuming its neutral oxidation state, or it is at the 0 charge now, right? Because that has fulfilled its deficient electron. So now this copper accepting the electron, so that's why this is the reduction reaction, that copper plus 2 has reduced into 0, means there is a shift and there is a change from plus 2 to 0, and that was 0 to plus 2, right? So it means that has given off the 2 electrons. I can write it for your understanding, though we have written it in equation. So now in this case, this is by accepting the 2 electrons, right? So one is removing the electron and another one is accepting the electron. So that is the reduction and the oxidation you should know. So these kind of definitions could also be the part of your examination, and you should know the definition, what the reduction reaction, what is the oxidation reaction, how this reaction is different from the combustion reaction or the synthesis reaction. Now, the next is the acid-base reaction. So you can check out the previous lecture on the acid and bases also, where we have discussed the ionic equations as well. So as the name states, the compounds such as acetic acid in lemon juice, the ethanoic acid in vinegar, or a typical laboratory acid like hydrochloric acid, all give their hydrogen ions away in a chemical reaction. So these type of reactions are known as the acid-base reactions. So we do check these reactions through the titrations also, and we use acidic and basic solutions, and we use an indicator which change its color in acidic or the basic medium, depending on what its form is and how it convert from the pink to colorless or colorless to pink. So we can change these physical or visuals by through the visual effects that now the acid and bases have neutralized. So the reaction between acid and bases, and where there is the transfer of hydrogen uh, as a acidic hydrogen which is liberated in the system. So that is the acid base reaction. So here the most common example is the HCl, sodium hydroxide, and that is converting into the water, and sodium chloride, which is a salt. Right now, you may ask, and don't confuse with that notation, that here I mentioned this as AQ. So AQ means this is an aqueous solution, that the reaction which is happening is in a medium, that we are using the sodium hydroxide solution, we are using the HCl solution in the water medium. So AQ is specifically for anything which is dissolved in the water. Now, another reaction is the replacement reaction. So the replacement means that something is exchanging or replacing another species or atom or group of atom. So that are termed as a replacement reaction. So they are the further two types. There is a single replacement reaction and there are the double replacement reaction. So single replacement reaction is where there is only the one kind of replacement, that there is the one element which is replacing another element. So this is a single replacement reaction. And in double replacement reaction, where there are two elements which are replacing the other element, two elements, so this is the kind of the double replacement reaction. So you can see, and if we write it's in a generic notation, so in a general form, so you can say like this is the A, and there is the B plus C, right? And the reaction is happening like A has C has replaced the B, right? And now the product is AC, and B has removed as such. So now this is a kind of single replacement, that the C has replaced the one element which is a B, and now this is the part of the A as one compound, and the B has eliminated. Now, in the double replacement, what will happen here is that you will take it like this is the A and B plus there is the C and D, right? So what you're expecting in the double replacement, so there could be the AC or AD, so anything you can write to represent that one, but of course you can't write AB again, right? So AD, and there is the B and C, right? So they are the two elements which has replaced the two elements. So there is the double replacement. So the equation for this is a calcium chloride and sodium this is a reaction with basically the we use with the glycerol. So this is for the soap formation as well. So now this is the small a, let me correct, this is a sodium salt with that one, and now we will get the sodium chloride because that has replaced, sodium has replaced the Cl, and this calcium has replaced this organic part of this equation, right? And now it has combined with this one to make that salt. So that is the kind of double replacement reaction. Now, the last topic for this is the energy differences between the reaction. So, when the reactant is converting into the product, so there are the two kind of energy changes which can happen. So, one is termed as endothermic reaction, and another one is the exothermic reaction. So, whenever you are traveling from the one point to another one, so definitely there is a certain kind of work you are conducting. You are using your kinetic energy, or maybe you are taking a bus. So you are changing your position, storing your potential energy. So in that way, when the reactants are converting from the one form to their desired product form, so they may need the energy to absorb, or they may have to remove the extra energy to acquire the conformation, the structure of the product. So on the basis of that, the reactions have termed as endothermic and the exothermic reactions. So here you can see the x-axis and the y-axis. So x-axis is the direction of the reaction, so where the reaction is proceeding, so it means it is basically to show up that from the initial point where there is a reactant, now eventually slowly that is converting to the product, and there is a stored chemical energy. So this is upward, this is increasing, that at the, if you just check out the figure, so from the figure you will be able to see the difference, how you can draw the difference in terms of the graph, that what is the difference between endothermic reaction and exothermic reaction. So I will explain that. So if you just check out the endothermic reaction, so endo means something is absorbing inside, right? So the temperature of the reaction medium from its internal energy will increase, right? So the product are of that form that they are uh, in a high energy, right? So the reactant has to gain or absorb the energy to convert into the product, because they are the sum of the stages it has to jump on to form the product, and it required the energy, because otherwise this is not possible for the reactant to convert into that product or to form that product. So the stored chemical energy initially when it is at the reactant level, this is lower, and you can see that there is a difference between the energy gap from the reactant product. The product are at the higher level of the chemical energy. It means the products have the higher energy than the reactant one. So when the reactants are absorbing the energy and then they are converting into the product, it means the internal energy of that reaction system will increase. So it is taking up energy from the surrounding. It means that is making the surrounding a colder. So if you are doing some of the reaction where you are um, dissolving some mixing the both reactants, and that is an endothermic reaction. So in endothermic reaction, what will happen, that the internal energy of the reaction medium will increase, but the surrounding will be on the cooler side, right? So that chemical energy is stored within that molecule. So as you can see, from the water and the steam, so steam has a more stored energy in itself. It is taking up, it is absorbing energy from though the steam is not the actual type of chemical reaction, because there is no change in the water molecule as such. So this is just of one physical form to another one. But just to make you understandable that how this is different from this one. So if you mix the potassium chloride in the with the water, so you will be able to see that this is the kind of endothermic reaction. So the direction of reaction is on that way, right? So reactants are converting into the product by absorbing that amount of energy. Now on the opposite side, if we will see the exothermic reaction, exothermic is the reaction in which the energy is evolved and this is given off to the surrounding. It means that the reactant, if the reactant is looking for a particular product, it has to convert to the product. So the product is of that kind that this is having the low internal energy, and the reactant has to release the energy to convert into the product one. So in that scenario, that energy which the reactant has to lost is the energy release, and that is given off to the system. So you can observe that from the warmer condition of the reaction. So sometime if you touch the beaker or the a glassware, so if this is warmer from outside, so it means that is an exothermic reaction. This is liberating, this is generating the energy. So the signs which we usually use to mention that the reaction is exothermic or endothermic, so for the exothermic reaction, the sign used is plus, delta H, enthalpy, right? So it means the plus means that is liberating, that is given off to the surrounding. And the endothermic reaction system, we use a minus sign, that this is absorbing the energy, right? So the endothermic reaction are the reactions when you are, these reactions you are conducting in a lab. So overall, when you will touch your glassware, that will give you the cooler effect. And if you will touch your glassware, so that in case of the exothermic reaction, so that is warmer for the surroundings. So their internal energy is cooler and the surrounding will be the hotter one. So that was the difference between the chemical reactions, the laws they fulfill, they obey to convert from the reactant to the product one. So you should know about this one. Now going back to the previous slides, I have an assignment for you that I have mentioned there are the four kind of physical effects by which, or the observation you can notice when the reaction, chemical reaction is happening. So just write the two examples of each in your around your surrounding, not necessarily the chemical, the laboratory reactions, but in your surrounding, in your daily life, you can take any examples. So you have to write the two chemical reactions for each category. One is where there is emission of heat or the light. The second is when you are able to see the precipitation. Precipitation means there is a solid product which is formed. So that could be of any color, that could be the white. So that has settled from the liquid. And the C category, that you are able to see the evolution of the gas, and the D is the color change. So you have to submit that task on the Moodle and write two for each category, right? So have a good day, and you can ask if you have a question. So you can comment, you can write to me. I'll love to answer you. Thank you. Have a good day.